in this session we will see about the importance of calculating the support reactions. Okay, so before getting into the this topic, we will recall some some important things. The beam is a very important member. So what is the use of the member? For what we are using the beam? It will transfer the loads from back to back slab to the foundation. Yeah. So we are calling this beam as a flexural member. Okay. So here, if you are taking the support, the beams can be supported by some supports. Will you please name the types of supports? Name of the supports? Roller support, hinge support, and fixed support. Okay. So likewise, what are the types of beams? Fixed, right? Types of beams. So simply supported beam, cantilever beam, then fixed beam, then continuous beams. Okay. So depending upon the requirement, we will choose the type of beam. Okay. So what are the types of loads? UL, point load, UL. Okay. And here the importance of studying about this is the support reaction will be depending upon the type of beam and type of load. So that's what we have to know about the things. Okay. So what is the reaction? What is the Newton's third law? Every reaction there will be a reaction. Okay. For an example, if I am taking this beam, okay, so the slab load will be the action, and the beam again will transfer to the supports. Okay. So the beam load is nothing but a load, and the reaction which is provided by that true support is nothing but a support reaction. Okay. So now in this case study, we will see that. So what is the importance of support reaction? If you are wrongly calculating the support reaction, so what are the things will happen in the building? So we will see the things one by one. Okay. So now if you are seeing this, you can see the different types of supports. I think you have seen this. It is in bridge. This is a roller support. Okay. The hinge support, you can see that in our door. It is a just example for the hinge. Okay, so likewise we can see the supports everywhere. So and also here, what is the type of support we are building? This building is a fixed support. Okay, and the support reaction will be depending upon the support. So what are the equilibrium equations we are using? Summation of vertical forces equal to 0. Moment equal to 0. Okay, to calculate the support reaction, we should know this equilibrium conditions. Okay, and if you are seeing that, what is the importance of support reactions? What it will give to the building? It will give the structural stability. Very good. Next, to calculate the bending moment and shear force. Okay, and it will transfer the load from slab to the foundation. Okay, and also it will prevent the movement of the building, and also it will maintain the building in the equilibrium. Okay, and here and also to give the better optimized material and cost effective structure. If you are calculating the support reactions in correct manner, you can give the building as an optimal building. Okay, so these are all the importance of calculating the support reaction. So here, if you are seeing that fixed support, how many reactions will be there? The fixed support, there will be a 3 reactions. Fixed support, there will be a 3 reactions. One is the vertical, one is the horizontal, and another one is the movement. So likewise, the roller, how many support reactions are there? 1. The roller, so there will be a the roller one support, the hinge support, there will be a 2 reactions. One is the vertical and one other horizontal. So if we are taking this, so the case study here I have taken as the building. So they have taken it as a fixed support, but while they have designing, they didn't consider that structure as a fixed support. So that they have imagined the given structure as a simply supported. Okay, so here you can see the collapse what it has happened here. Okay, so therefore but finding of the support reaction is very, very important. Okay, and here we can see this where we are using. So this is the example for fixed support. Okay, and also you can see this is the best example for hinge support. So similarly, you can see these types of structure in some industries Okay, so this is the best example for the hinge support. Okay, and similarly you can see this. So here this is a roller. So here you can see this. This is a bridge. Okay, so there will be bridge girder will be there. Will be supported by a piers. Okay, in intermediate of beam and the pier, there will be the roller will be fixed. Okay, so you can see this. The structure is collapsed due to that insufficient provision of the support. So for an example, here they have given the roller. So nowadays, instead of roller, we are using some elastomers pads. Okay, it will absorb the load in the places where earthquakes are happening. They are providing that pad. It will absorb that energy during the earthquake and it will release. Okay, so depending upon the building, the place where it is situated, and what are the loads which are acting. So depending on that, we have to choose the supports for the building. Okay, so here this building is this bridge is collapsed due to the insufficient support they did provided. Okay, so I think you have understand that what is the importance of the support reaction. So now similarly you can see this. Similarly, we are using this. We are naming this support as a simple support. Okay, and where we are using these, you can see that you just in bridges. So in bridges, you can see this. Here, this is a bridge. Okay, so what it is moving there? Some vehicles are moving there. So what is the type of support they have given here? The one is a one side roller and another side is a hinge. We are calling this support as a simple support. Okay, so here this in simple suppose they did provided properly, this the load will not be transferred to the columns properly. Okay, so here the action is nothing but self weight of the bridge deck and also the moving vehicle, and then reactions will be given by the supports. Okay, and similarly how the load transfers are there. So slab to the adjacent beams and again to the columns. So what is the type of load here? It should be considered as a uniformly distributed load. And what is the type of support? It is a fixed support. Okay. So if you are not properly understanding this, what is the type of load and what is the type of support, you can't design the structure properly. So when you are doing we are using the STAT. The name of the software, we are using this STAT. So while we are giving that input to the software, we have to give the what is the type of support and what is the types of load, everything. If you are not giving the input properly, then there will be the failures will be happen like this. Okay. So here the another example, the support reaction. So this is what is the name of this thing? This is a hinge and what is the this is the cranes. Nowadays, due to the insufficient manpower and due to the we are going for more number of stories. So where we can't shift the building material to the upper floors. So where we are using the cranes. So there also that cranes will lift. This will be properly designed and we have to consider the what is the type of support they have given. Okay. So or otherwise it will be failed due to that. During that lifting of the vehicle. Okay, and here you can see this the movements are moving. Okay, so it is that environmental thing should be also the considered. There will be if I am taking this a Ooty. Okay, so there will be heavy rainfalls will be there. So due to that also the loads will be sudden loads will be happen. If you are not providing the supports properly, what will happen? There will be the collapse of the structure will be happen. Okay. So in this video, I think you have understand. So what is a beam? Beam is a flexural member. Okay, what are the types of load? UVL and point load. What are the types of beams? Cantilever beams, simply supported beam, fixed beam, continuous beams. Okay, and then what are the supports? Types of supports? Roller and fixed. So what are the how many reactions will be there in roller? 1. Hinged. 2. Fixed. 3. Okay, and everywhere we are using. So where we are using the support reactions, bridges, designing of bridges, buildings, okay, and also the cranes and machineries. So everywhere we are using. So as a civil engineer, you should know that the importance of calculating the support reaction. Before that, we have to know that what are the types of force, everything, and also the building, where the building is situated. If it is an earthquake prone area, we have to consider the earthquake load also. So where the wind velocity is more, then we have to consider the wind velocity also. And also it is very depending upon the type of structure also. Here where you are sitting is a educational building and your home is a residential building. So where the light load will be different. Okay, so depending upon the structure also we have to design the building, or otherwise you can see the collapse how it is happened there. Okay, as a civil engineer you should know these things. So thank you for listening this session. Thank you.